So in the previous video, we looked at the basic interface of a Jupyter Notebook, and I took you through some examples as to the markdown and the cells, how they work. So you're welcome to look at that video in one of the links on top here. In this video, part 2, we're going to be looking at the main types of collections of variables. Briefly, what I would recommend is if you want to go into more detail, there's a lot of information on the internet. But just to put you at ease as to what the expectations are for basic coding, we're going to be looking at 4 main types of collections of variables. These are lists, tuples, sets, and dictionaries. As I mentioned in the previous video, this cell over here would be a markdown cell. Double click on it, you can see that I've used the hashtag for a main heading, 2 hashtags for a subheading, and then I've listed this over here. You can see it's marked as a markdown over here, not a cell that generates code, so it's a markdown. If I press Shift Enter, you will see that it generates that nice heading, very nice and neat for a reader of this particular notebook. Makes it nice and presentable, as opposed to if you double click it, you don't want the reader to see that. So you press Shift Enter and then it's nice. So let's look at lists first. Lists are ordered and mutable collections of items enclosed within square brackets. That's important. It allows for modification, addition, and the removal of the specific elements within the brackets. I have several other videos where we look at lists and all these different types of data collection variables. Have a look at the other videos if you want to have more explicit examples. But let's look at a simple example over here. So what I've done over here now is I've given you the 2 comments as I just read out. If I highlight it in blue, that means it's ready to be run. So if I press Shift Enter now, it will run this code. Firstly, I tell Python to create a variable called simple list, square brackets, are the elements John 3, 1, 3, study. You'll notice that string variables or string elements are in inverted commas, single inverted commas, right? If it goes brown, then you know that it will take it verbatim like it is in there. Study, and in this case, John over here. And the last element is 3.88. So we know John is a string. We know 3 is an integer, 1 is an integer, 3 is an integer, study is a string, and 3.88 is a float because there's a decimal. What I do then is I tell it to print simple list. What I've done for you here is I've given you comments to help you understand the respective lines of code. So do that. Very useful and very sensible thing to do. Whichever line of code you have, put a comment there. It explains it to the reader. Remember, the reader could be your boss. The reader could be your professor at university. It could even be a client that you are running this code for. Put a comment with a hashtag next to the respective code to inform whoever's reading your notebook. Here I say print the simple list, so it's going to print that. Then I say print simple list 0. How Python works is, you will see there are 1, 2, 3, 4, 5, 6 elements in this list. John, 1, 2, 3, 3, 1, 4, 3, 5, study, 6, 3.88. But how Python works is the first element is not number 1, it's number 0. So if I'm telling Python to print the simple list, which is this list over here in line 4, but only print the first element, 0. You'll see it'll print John. Then I say, print the simple list, the third element. So it's 0, 1, 2, 3. So it's actually the 4th element. So that'll print 1, 2, 3, 4. It'll print the second 3. Then if I tell it print -1, what that means is it's the one before the final bracket. The final square bracket. So -1 is 3.88. You can tell it through the code to generate or identify an element from the beginning of the list as well as the back end of the list. If it's from the beginning of the list, it starts with 0. So the first element is a 0. If it's from the back of the list, it starts with -1. So the second last element will be -2 and so forth. So if I print simple list -2, you are going to get study. If I print simple list -6, it's going to be -1, -2, -3, -4, -5, -6. So it's going to be John. So John will be generated with a -6 in this case, but it will also be printed with a 0. And then finally I say print simple list, but the length. In other words, it prints the length or the number of elements in the list. So there are 1, 2, 3, 4, 5, 6. You would expect 6 to be generated. So I've clicked on the cell, it goes blue, press Shift Enter. The simple list prints the entire list. You can see 0 is John because it's the first one. It starts with 0. Print number 3, so it's 0, 1, 2, 3. It's the second 3. Then it says print -1, so it's the first one from the back. In other words, the first one from the closed square bracket at the end. So it's -1 will be 3.88. Study will be -2. -6 will be John, as I explained. -1, -2, -3, -4, -5, -6. Then print the length or the number of elements. 1, 2, 3, 4, 5, 6. Output is 6. What happens now if you want to change specific entries or elements? So you've got a list over here, but what happens if you want to change John to, say, Peter? Or you want to change that 3 to a 4? Or you want to change this 3.88 to 9? Whatever the case might be. That's what this next line of code is. You can change the entries within a list. Let's do it when we run the code, and then we can explain it from there. The first line of code is simple list, the third one. So that means it's the fourth element. 0, 1, 2, 3. So it's the fourth element. So what you want then is you want to replace the fourth element, in other words 3 in this case now, with a 52. So in other words, if I ask you to print simple list, the 3, which is the fourth element, that 3 has now become a 52. This line of code is telling you to only output that one specific element. So there it is over there. Then you say, by using the .append function, it adds another element. Simple list is the data frame, which you call the data frame, the list itself. .append, you are adding to the back. So whatever the final element was, you are adding an additional element, and now we're calling it in this case now to the back. We could have called it a 3, a 4, whatever the case might be. So you'll see if I print simple list now, it has changed from the original one up here. The 3 has become a 52 because of line code 3 and 4. Then there is an additional element at the end based on lines 5 and 6. And then we say print the length. It should be 7 because we've added to the back because there was 6 originally. So the output is now 7. 1, 2, 3, 4, 5, 6, 7. Then we say simple list .pop function. And what this does is it removes the element, the respective element in the list, at that place. So in other words, 4, which means the fifth element. Why? 0, 1, 2, 3, 4. So it's the fifth element. So in other words, it's going to be 1, 2, 3, 4, 5. So study is going to change. So we want to remove this study. So you'll notice that if I print simple list, we've removed study using the .pop function. So you'll notice the output, there's no study. 52 now is followed by 3.88, where previously study was there. These lines of code here, what you are able to do is you can change values, you can add values, as well as delete values or elements in your respective lists. You can also quickly make a list with a particular number and where they are all the same. So if I generate this code or run this code, if I call it repeated list equals close brackets 9, that is the value of the element, multiplied by 7. So in other words, there must be 7 values of 9. Notice it is not 9 multiplied by 7. Why? Because there are square brackets. So this part in the bracket is a list. So it's a list with a value 9, in this case now. Where if you remember up top here, the list that we created had 6 elements. And they were all different. Well, John 3.13, study 3.88. Now we are creating a variable called repeated list with only one variable in it, 9. But we are telling the code to use that value 9 and repeat it 7 times. So we print repeated list, there should be 7 9s. 1, 2, 3, 4, 5, 6, 7, 9. What you can also do is you can use lists as entries of a list. What do I mean by that? Let's press Shift Enter to see the code. So here I say simple list. The first value should be 9, 55, and 0. So what am I doing? I'm calling the first value, which is actually the second element. Remember, it starts 0, then 1. So the second element is a list of values 9, 55, and 0. So it's a list within a list. So if I print that, you'll see John. Remember, if we go up to the output up top here, John is the first one. The second one is a 3. So now we are saying replace that 3, because the second element, denoted over here, replace that 3 with a list that is 9, 55, and 0. So there you can see the output. And the rest stays the same as per the output up top here in line of code 8. Then I say print simple list 1, which is the second element. So it just prints the list. Then I say print simple list 1 and 2. So then I say print simple list, square brackets 1 and 2. What this means is, look at the second element, which is the list in the list, but print only, generate only, or the output only for the 2, which is actually the third element. So the third element within the sublist of element 2 is 0. So that's the output. So this 0 here reflects that 0, which is the third element in the second element of the list. So it's the third element in the list of the original list. So you can play a bit around with it. You can even copy lists, but this raises a few problems. So let's look at that. So if you copy a list, you'll see here, if I call it list 2 is equal to list 2, so it generates a copy. Remember now, up top here we called it simple list. Right up top here we called it simple list equals that. If I create the code, list 2 is equal to simple list as above. So list 2, I make a copy of that. I create the variable list 2 and I say it is equal to simple list. Then I print list 2. That's the printing of list 2 over there. Then I say print simple list, and of course you would expect it to be the same because I've created a copy. Then what I do is I say in list 2, the second element, in other words, remember 0 then 1. So I change the second element, 1, to a 0. Then I print list 2, but then look what it does. If I print the simple list, which is what I made a copy of originally, it also changes the second element. But I didn't instruct it to change the second element in simple list. I instructed it to change the second element in list 2. And that's obviously a problem. So you could be creating lists, you change elements in the copy of the original, then when you change the copy, the original one also changes. That's not ideal. So what can we do to avoid that? We can use the .copy function to avoid this problem. So if I run this code, you will see if I create a copy of the simple list, so list 3 is equal to simple list.copy. If I print list 3, that is the output. If I print simple list, that is the same output because you've made a copy. But now if I change the first element, 0, in list 3 to Mitchell, so I'm changing John to Mitchell, you will notice if I print list 3, Mitchell has changed. But if I print simple list, which was the original, John has not changed to Mitchell. And that is because you used the .copy function. So instead of generating copies and thinking that if you amend or change elements in one copy, that it will not change the other copy, instead of doing that, which the problem is that it will actually change the original copy, rather use the .copy function. It's a lot simpler and a lot easier, and it creates a lot less confusion. For a NumPy array, remember we'll be talking about libraries in a later video. When we use examples of actual data, we can create a list over here with these respective elements. If you use this list over here, you can highlight or identify specific values using the semicolon function. But be careful. Let's look here. You can see print simple list 2 semicolon 5. So in other words, 2 means the third element. So it's 1, 2, 3. So it starts at 1, semicolon up until 5. But with this list in the square bracket, that 5 is excluded. So in other words, it's only value 4. So it's actually 2 to 4. But remember now, 2 is the third element and 4 is the fifth element. So in other words, it is 1, 2, 3, 4, and 5. Therefore, it's 1, 2, 3. So it's these 3 over here. So it's the third one, the fourth one, and the fifth one. Not the sixth one, which is what this fifth is. So if you print simple value 2 and 3, it'll be 3, the third element, but excluding the fourth element. So it'll be 1, 2, 3, it'll be 1, but excluding the fourth element. So it will not be 2. So it'll only be 1. So if I print simple value minus 5 and minus 1, if it's a minus value, you start from the end. If it's minus 5, it is 1, 2, 3, 4, 5. So the first one is the 5. The second one is the 3. The third one is the 9.9075. And the fourth one is the minus 286. You do not include the final one, because the final one, in this case now, minus 1, is minus 88. So you exclude the final value in this bracket if you are using NumPy array. So this explains it quite clearly. So keep that in mind.